C2, the binomial expansion, past paper question, January 2008. So, in this first part, we have to find the first four terms in ascending powers of x of the binomial expansion 1 plus kx to the power of 6, where k is a non-zero constant. So, a 1 plus kx to the power of 6 will be equal to 1 plus 6 lots of kx plus 6 times 5 over 2 kx squared plus 6 times 5 times 4 divided by 2 times 3 lots of kx cubed. That's 1, 2, 3, 4. So we've got our first four terms. Now I'm just going to simplify these. So I'll have 1 plus 6kx plus 6 times 5 gives me 30. 30 divided by 2 gives me 15k squared x squared plus 6 times 5 gives me 30 again, times 4 gives me 120. 120 divided by 6 gives me 20k cubed x cubed. Remembering that the k and the x in each of these brackets is squared and cubed respectively. So that is our answer to part A. On to part E. Given that the expansion, the coefficients of x and x squared are equal, we're asked to find the value of k. So part B. So x, we've got this here. So we know that 6k is equal to this here, 15k squared, because we know that the coefficients of these two are equal. So that means that 15k squared minus 6k equals 0. So k, lots of 15k minus 6 equals 0. So k could equal 6, or 15k minus 6 could equal 0. But in part A, we are told that k is a non-zero constant. So that means that it cannot be this one. So we have 15k equals 6. So k equals 6 over 15, which is the same as 2 over 5. So now we've found our k. And then in part C, we're asked to work out the coefficient for x cubed. So x cubed, we've got 20k cubed. So C, we have 20k cubed for the coefficient of x cubed. And we know that k is equal to 2/5. So that means that we have 20 lots of 2/5 cubed, which is the same as 20 times 2 to the power of 3, which gives us 8, divided by 5 to the power of 3, which gives us 125, which is the same as 160 over 125. And both of these can be divided by 5 to give us 32 over 25, which is the coefficient of x cubed.